All right. Let's look at this first one here. Ooh. So I've got negative 3x over x squared minus 9, and we want to know when that's greater than 0. So, all right. So what we need to do is we need to find our roots or our zeros. So what do we need to do here? Yeah, this guy is a difference of squares. Let's factor it. I need roots. So my numerator is going to stay the same. We still have minus 3x. But my denominator is a difference of squares. So we can write this as x plus 3 and x minus 3. What's up? So hot in here? I've got the window to outside open, like trying to pump in outside air, but it is not cold in here. I agree it is warm, but this room does get wild temperature swings. The only options are 85 and 60. There is no in between. Okay, so we have everything factored. Let's find our zeros. What are our roots or our zeros? We have 3, and we have negative 3. Anything else? And 0. So we got to take all of our pieces. This numerator has one too. Minus 3 times x. So we have a root at 0 as well. Any place there's an x, we have a root. So we're going to do this just like we did yesterday where we set up that kind of number line. I'm going to put my root values here. So I'm going to go negative 3 and then 0 and then 3. And I'm going to take all of those pieces. You go pass?
Teacher.
Okay, as long as they sent me an email, I've got to attend this first. When we're putting down our factors to find our positivity, we need to take our numerator and both pieces of the denominator because all of those things are essentially being multiplied together. So we're going to put our minus 3x and x plus 3 and x minus 3. And we're going to do our positivity for all these pieces. So I'm going to do this without us necessarily doing a specific number this time. So if we have a number that is smaller than negative 3, so more negative, is this product going to be positive or negative? I have negative 3 times whatever this negative number is, right? So that's going to be positive. If I have a number smaller than negative 3, is this piece going to be positive or negative? Negative. Is this piece going to be positive or negative? Let's see. Negative. So you don't have to use a specific number. Yesterday we were just practicing it with a specific number. That is an absolutely fine way to approach it, but you don't have to use a specific number. So then we're going to think about between our negative 3 and our 0. Is this piece going to be positive or negative? Positive. Positive or negative? Positive.
Negative.
And negative. All right, we see this? Okay. This one.
Negative.
Negative. So we're between 0 and 3 now, so we're into some positive numbers. Positive times a negative gives me a negative. Positive.
Negative.
negative. And then we're going to do bigger than 3,
Negative.
negative,
Positive.
positive, ooh, positive.
Oh, my bad.
I would say we were flying through. Questions on any of these? What I want you guys to notice here. Every single row only changes its positivity once. And they all change at different places because this one's root was the -3. This one's root was the 0. This one's root was the +3. Okay, so that's what's happening there. And that's why they're all changing in different spots, is they change where their root is. That's where that specific root changes its sign. Okay, so that's why it's really important we find our zeros first and use those for our positivity table. So we're going to find the positivity of our function. We do that by multiplying all these down. So a positive times a negative times a negative. Positive. Then we have a positive times a positive times a negative. Okay? Negative, positive, negative gives me a positive. And then negative, positive, positive. Slow down, thank you. Negative. It will not always alternate, so it is important to check all of them. Sometimes we may have double roots, which will cause us some weird positivity things. So it's important to check that. So, looking back at our question here, are we looking for positives or are we looking for negatives? We want to know when this piece is greater than 0. So we want this thing to be positive. Do we want it to be equal to or just positive? Just positive. So when we're writing our intervals, are we ever going to use a bracket? Nope. So we're looking for our positives here. So putting this into our interval notation, what's that? Mm-hmm. So how do I write this piece as an interval? Not -3 and 0. This one. What is the smallest this segment is?
Oh, negative.
Negative infinity. This one continues onwards. If it doesn't have an ending side on the left, it's continuing onwards. This goes from negative infinity up to -3. We don't want the negative one, so I'm going to skip that one. So let's do this one in here. How do I write this as an interval?
0 and 3.
0 to 3. Both of them get parentheses because we're not including our zeros on this time. We didn't want equals to. What's up? Because that's where the end of this wall is. This wall is at 3. What's up? When we looked at our problem up here, we wanted to know when this piece is greater than 0. Oh, my laser pointer stopped and my screen's freaking out. When this piece is greater than 0. Greater than 0 means it's going to be positive and not negative. So we want the positive values when we multiply all these pieces together. Okay? So we need this interval union with this interval. Our two positive sections. What's that?
If it were less than, it would be, you would use a negative first.
Yes. If it had the same exact fraction and it said less than 0, we would do our negative intervals.
So it would be -3, 0, and union would be 2.
Correct. And if the difference was that it had an equals to, we'd put our square brackets on our numbers. What's that? It doesn't. That's a parenthesis. I'm just bad at it. Since it was a less than or a greater than, nothing's equal to. Like we're not including the 0. 0 doesn't count. I need it to be greater than 0, not greater than or equal to. If it was a greater than or equal to, we would have brackets on the numbers. What's up?
So like, this kind of problems,
Mm-hmm.
you gotta do that on the chart.
Yeah. I cannot think of a way that you can do it without the chart. I've tried, because the chart's annoying. But we will use it again later when we're doing other things, when we're trying to graph this kinds of stuff, we will use the chart again. Okay? Because we're going to graph like all kinds of wonky polynomials. Okay. Now we're going to look at the one on the right, which is really similar, but also kind of not. Because it's not greater than 0 this time. It is greater than 2, which is not as easy. Because we don't have a shortcut for positive, negative for how to be greater than 2. So what we're going to do is we're going to make it be 0. So we're going to come into this one here. My x plus 1 over 2x minus 3 greater than 2. And we are going to make it equal 0. Or make it be 0 over here. Make this 0. We can do it if it's greater than or equal to 0, or like greater than 0. We can do that. That's positives versus negatives. There's not a shortcut for that on 2. So we need to make that 0, just like we did in quadratics, to set things equal to 0. So what can I do to get the 2 to go to the other side and make the right-hand side 0? Subtract 2. So when we subtract 2, we're going to have our x plus 1 over 2x minus 3 minus 2 is greater than 0. We've seen problems kind of like that before. Yes, we have. Or at least we've seen things like that before. How do I simplify that? Common denominator. I want to subtract these two pieces. I need this to have the same denominator.
That was a whole, like,
So I need to multiply my 2 by what? Times the fraction of 2x minus 3 over 2x minus 3. I need it to have a common denominator. So we're multiplying it by a funky looking 1. So I'm going to write it out over here. So we have our x plus 1 over 2x minus 3. This part isn't changing. And then we're going to subtract our new fraction that has our denominator of 2x minus 3. What is in my numerator? It's like you pull the minus sign in. That's absolutely fine. Totally fine. I just did none here. So I'm going to do it as 4x plus 6. But you're absolutely right. When we're subtracting it, it's going to be minus 4 and minus 6. And I'm going to bring my inequality down. Minus. Oh, it should be, yeah, minus. Sorry, my signs are weird. It should be a minus 6 here. Because I took my 2 and multiplied it in. If you distribute the minus 2, that's fine, but you're going to wind up with a plus over here. So be careful of your signs. We were just talking signs while I was writing signs, and it made my head go wonky. Okay, cool. So now that I have those as common denominators, our denominator is 2x minus 3. We have x minus 4x.
It's
Negative 3x. 1 minus negative 6. Positive 7. Questions on that part? So now we're into exactly what we've been doing today and yesterday. Find our roots, set up our positivity table. So what are our roots here? 3 halves, that's our denominator's root.
7/3.
And 7 over 3.
They're all extraneous.
We're not testing extraneosity.
Oh, wait, so you used to do 3 rows.
Yep, so we're going to set up our positivity table now. But questions on here? I don't know how I got 2 here from here. But since I'm scrolling it off the page, I like to make sure we see. Okay. So we're going to set up our table. I'm going to have my number line. We just need to be careful and make sure we're putting things in order. So my 3 halves is smaller than my 7/3. And so my factors are my minus 3x plus 7 and my 2x minus 3. I don't know why I did those bright pink. I'm going to switch those out to purple. Okay. Let's think through our positivity here. If we have a number that is smaller than 3 halves, what is this one going to be? Positive. If we have a number that's smaller than 3 halves, what's this one going to be? Negative. If we have a number between 3 halves and 7/3, is this going to be positive or negative?
Positive.
Positive. All right, what is a number between 3 halves and 7/3? 2. Because this is about 1 1/2, this is 2 1/3. So 2 is right in between. Negative 3 times 2 plus 7. 1, so it would be positive. So if we do the same thing, thinking about 2 here, on this bottom one, positive. Because 2 times 2 would be 4, minus 3 would give me a positive 1. So look over here. Bigger than 7/3. You can think 4. Is this going to give us a positive or a negative? Negative. Is this one going to be positive or negative? Positive. Okay? So for our function, our positivity down here, positive times a negative gives us negative. Positive times a positive, and then negative. Are we looking for a positive or a negative? A positive, because it says greater than 0 up here. So our interval is this one. It's going to be from 3 halves to 7/3. Are they going to have parentheses or brackets? Parentheses. No, that is not all we're going to do today. Nice try, though. What's up?
So like when you have like multiple zeros, then we have
It's if we have things like this one could have had a union if we had it be less than 0. If we needed our negatives, because we would have 2 solutions here, 2 solution sets. So the union is if we had more than one set for our solution. So if this had been less than 0, I would have had this interval and this interval. Those parts would be any negative. So we use the union if I have more than one interval, because we just combine them together. We're going to practice this some more. Okay. Ready?
Yes, I'm proficient.
Let's look at this one.
Oh no. That's 2x.
X squared minus 9 over x cubed.
I think NASA used this. Yeah, NASA. It's advanced. Actually, it's not. It's like easy. This beginners for college.
Okay. So what do we need to do here? More specific. Find the roots. So first things first, we need to do what? Factor that numerator. My numerator is a difference of squares. So what is this in factored form? Yeah, you're exactly right. And our denominator can just stay x cubed. Like, that's totally fine.
And now we solve. No, like I mean like this square thing.
So let's look at our roots. We need our zeros.
We have 3 zeros. Why?
What are our roots? 3, -3, and 0. Denominator.
0, 0, and 0.
Yeah, and it would be a triple root through 0, but 0 is enough. So let's set up our positivity table. Start with my number line. I'm going to have my -3, then my 0, then my +3. For my factors, I'm going to put my x plus 3, my x minus 3, and you can do x and x and x, or you can just do our x cubed. That's the easy way to do it, is to put it as x cubed.
Let's put that way.
So let's fill in our positivity table. If we have a number smaller than -3, is this piece going to be positive or negative? Negative. If we have a number smaller than -3, is this positive or negative? -3 minus 3?
0.
-3, or even if it's -4, because we need smaller than -3, right?
It's a negative.
It's a negative value.
That just shows me that.
So smaller than -3,
Negative.
cubed,
Next one is negative.
negative.
It's squared.
Squared would be always positive, but cubed can be positive or negative. Okay? So now we're going to do our between -3 and 0. If you want to think about a specific value, you can. So our first piece here, positive, and then negative, and then negative. Between 0 and 3. This one. Positive. This one. Still negative.
Ooh.
And this one. Positive. This one. Positive. Positive. Positive.
So like once the sign changes, it's gonna be the same for the rest.
Yes. Otherwise, your piece isn't fully factored. If it changes signs again, that means it turned back around, so you had like a quadratic in there, and you wound up not at your zeros. So let's do our positivity of our function. Negative, negative, negative gives us,
Negative, positive, negative, positive.
yes, so negative, positive, negative, positive. What are we looking for our solution set? Greater than or equal to 0, right? So we want our positives. Before we get too far into writing our intervals, since we want this to equal 0, but we had a fraction at the beginning, are there any of these that are not allowed to be in our denominator because it would make my denominator 0? 0. So 0 is not included in my solution set because it makes my whole system undefined, right? Because it's dividing by 0. So when we're putting it into our interval notation, pay attention to the fact that 0 is excluded. So how would we write this as an interval? Bracket, -3, 0, parenthesis. I can get all the way up to 0, but it cannot equal 0. Otherwise, my denominator is 0. How do I write this one as an interval? Bracket 3 to infinity. No beyond. Infinity can't go beyond. Buzz Lightyear's wrong.
Oh.
And union them together. Yes, my dear.
Oh.
Because if we look back at our function,
I think I'm good.
if x was 0, I would have a 0 in the denominator. And 0 in the denominator makes our whole system break. It's an excluded value. Okay. Say it again. From -3, because this edge was our -3. So from -3 to 0, we just can't include 0. And then we start back again at 3. Okay. Ready? Here's our next one.
No, but if they give like, what is it called? Scholarships and stuff, sometimes you pay for something. Yeah. I get a scholarship from Starbucks. They pay my Starbucks.
All right. So look over here.
I don't know anybody that would do it.
What do we need to do first? Set it equal to 0.
Like,
It has to equal 0. Has to be set equal to or inequality 0. 0 on one side. So I'm going to subtract my 2 over x plus 1 over. It doesn't really matter which one you move. But just so that we do this same thing, I'm going to subtract this one over. So we have 4 over 3x minus 2 minus 2 over x plus 1 is less than or equal to 0.
yes. What were you thinking? You better take it.
What can we do here? Common denominator so that we can subtract them.
Common denominator.
Mm-hmm. Yep, so we're going to need to take our 4 over 3x minus 2 and multiply it by what? X plus 1 over x plus 1. We're getting to a common denominator here. And then I'm subtracting 2 over x plus 1. What do I need to multiply this fraction by to get it to be a common denominator? 3x minus 2 over 3x minus 2. And we're still less than or equal to 0. Because I want it to stay equal to 0, which is why we're not multiplying to both sides of the equation. Otherwise, I'd wind up having to move things back over. So let's simplify this. I have the common denominator now, so I don't need to write it both times. We're going to leave it in our factored form because we want it in factors anyway. So our 3x minus 2 and our x plus 1. And our numerator, we're going to multiply this out. So I've got my 4x plus 4. And you can distribute your minus through right here. So minus 2 times 3x gives me minus 6x. Minus 2 times minus 2 gives me plus 4. So fully simplified, what do we have in our numerator? Negative 2x plus 8 over our 3x minus 2 and our x plus 1. All of that to get us started so that we can do our positivity table. Now we need to figure out our solutions to our inequality, which means first things first is I need my roots. You don't have to. You can, but you don't have to.
Do we do also the one in the numerator?
And the one in the numerator, because that would make my numerator equal 0.
So 4.
So 2/3, negative 1, and positive 4.
Oh my goodness, Liz.
So let's do our positivity table. Minus 2x. Oh, let me get my number line on here first before I start going wild with our factors. So we're going to have our negative 1, positive 2/3, positive 4. And our factors are our minus 2x plus 8, our 3x minus 2, and our x plus 1. And then I'm going to zoom it in so it's a little bit easier for me to write on. There we go. So we're going to do our, I don't know why I keep trying to draw those purple or pink. There we go. Doing our positivity table here. So if my x is smaller than negative 1, positive. If my x is smaller than negative 1, negative. If my x is smaller than negative 1, negative. And it genuinely does not matter if you fill it in this way like I do or if you fill it in rows. Like, it's totally fine if rows work better for your brain if you do it that way. Totally fine. You should wind up with the exact same positivity. So between negative 1 and positive 2/3, positive, negative, and the bottom one, positive. So then between 2/3 and 4, positive, positive, positive. And on the, what's up?
Negative.
So negative, positive, positive. Does everyone see where those come from? Okay. So our function positivity, bottom row. What do we have? Positive, negative, positive, negative. Are we looking for positives or negatives? Negatives. Are any of my roots excluded values? Which ones are excluded? the 2 over 3,
Negative 1.
because that would make this term 0, and we can't have a 0 in the denominator. So this guy is, ooh, wrong pen. This guy is excluded. And what was the other one that makes my denominator 0? Yeah, and the 2/3. I definitely wrote them in the wrong order, but that's totally what we meant. Okay, so neither of those can be in my denominator because it makes my whole fraction 0. So both of those are excluded from my solution set, even though it says equals to, because it makes my whole system undefined. So our intervals are going to be what? Parentheses, union with bracket to infinity. Not beyond, because Buzz Lightyear's wrong. You can't go beyond infinity. Then you weren't really at infinity.
That's a hypothesis.
Okay. One last one. Just this one. Just this one. Last one. Last one. What's this? What's this?
It's math.
It's math. What do we need to do first?
We need a subtract.
0 on one side.
Yeah, so that's a subtract. Oh yeah, we're at.
We're going to add 36. This one is not, it's not a giant one. I promise it's fairly short. So we're going to have our x to the 4th plus 13x squared plus 36 greater than or equal to 0. What do we notice about this?
It is a 4th.
It's a 4th.
U.
Huh?
U.
We could do a u substitution. This is a quadratic type equation.
That's my best.
I could set my u equal to what? X squared. So this would give me
U is my.
u squared plus 13u plus 36. So what is this going to be factored form? It's going to be 9 and 4, right? U plus 9 and u plus 4. Right here, we're going to put our u back in. So I'm going to put it back to get me my x squared plus 9 and x squared plus 4. So I put my u back. Does anyone see why I put my u back right here? They are perfect squares. Are we looking for positives or negatives? Look at our inequality. Positives. We want the left side to be bigger than 0. We want it to be positive. Is this chunk ever going to be negative? No. Because x squared is always positive. Plus 9, still positive. Is this chunk ever going to be negative? No. Again, x squared, always positive, plus 4, still positive. So is this function ever negative? No. Not. So when is it positive? Always. All real numbers. This is always positive. Told you this one was shorter.
Well, that's just kind of interesting.
So our interval goes from negative infinity to positive infinity.
What? How's it always positive when it goes?
What's up? Huh? Oh, yeah. You could absolutely do that. Totally fine. All real numbers. I was gonna say I would love us to do interval notation, but I'll take all real numbers as well.
Can I do
Yes, if you need a copy of your review, they are up here in this green folder right here. I have found one typo on it, just so that y'all are aware. The first question, has a typo in it. It should say -3 in your restriction, not +3. Please make sure you make up any missing quizzes before the test, because I'm going to pack back all the quizzes tomorrow. I'm passing them all back. So if you haven't taken it, you're just going to have a 0, because I'm passing them back, and you don't get to take it after they're passed back. All right, make sure you're checking that registration stuff. That has to get done this week. If you have problems with it, contact Ms. Volin. She's in charge of the IU parts.
I'm not going to do that Friday.
Okay,